A loan can default, or it can get paid off early. Both end the loan, but only one is the risk you care about. So which one does a borrower's profile actually drive? The fine gray model. It estimates the subdistribution hazard for competing risks. Picture a portfolio of 600 consumer loans, each followed for up to 5 years. By the end, 259 had defaulted, 237 were paid off early, and 104 were still active. Default is our event of interest. Payoff is the competing event. The key idea: instead of an instantaneous rate, we track the cumulative incidence of default, the actual probability a loan has defaulted by a given month. Two groups of borrowers, prime and subprime. Prime loans climb to about 27% default by 3 years. Subprime loans climb far higher, about 55% over the same window. At 3 years, that's a 28 percentage point gap in absolute default risk. The fine gray model turns that whole separation into a single number. The formula: the subdistribution hazard for default is a baseline hazard times e to the beta times the covariate. Exponentiate that coefficient and you get the subdistribution hazard ratio. For subprime loans, the estimated subdistribution hazard ratio is 2.43. With a 95% confidence interval from 1.88 to 3.14 and a p-value well below 0.001. How to interpret it? An SHR of 1 means the covariate has no effect on the cumulative incidence of default. Our estimate sits at 2.43, and the entire confidence interval stays above 1. So subprime borrowers reach more than twice the cumulative incidence of default, a clear, significant increase in absolute risk. Why it matters? A naive Kaplan-Meier curve treats early payoffs as censored, as if those loans could still default. It overstates subprime default at 4 years as 73%. The proper cumulative incidence is 57%. That 16-point gap is exactly the bias fine gray removes by keeping competing events in the risk set. When to use it? Reach for fine gray when competing events are present and you care about absolute risk, the cumulative incidence. If instead you want the instantaneous cause-specific rate, fit a cause-specific Cox model. Here, the two agree. Its hazard ratio of 2.28 tells the same story. Try it free at MetricGate.com.